Okay, so section 1.6 is hardly anything new. When I started writing section 1.5, it just got too long for one lecture, so I split it into two sections. So it's going to feel a lot the same. If you're comfortable shading the Venn diagrams, then what we do in section 1.6 won't be a really big, won't be that hard to do. Essentially, in this section, instead of having Venn diagrams that are blank with nothing inside the sets, we're going to fill up the diagrams with letters and numbers, and then use the filled in Venn diagrams to answer intersection, union, and complement questions. And if you have your work for section 1.5 handy and it's somewhat organized, it might make this section go a little bit quicker, and you'll see what I mean when I get to the problems. That's assuming I'm organized enough to find what I need, and I may not be, so I might have to do more work than I want to. So one skill we need to have is, if we have a Venn diagram that's filled in, we need to be able to pick out the sets that are described by that Venn diagram. And so here's a Venn diagram. Notice I didn't put the name U in the lower right hand corner or some region outside the Venn diagram. And what I'd like to be able to do, this Venn diagram represents three sets. Anything inside the rectangle would be considered part of set U. Anything inside the A circle will be considered a part of set A. And anything inside of the B circle will be considered a part of set B. And what I want to do is just simply write down the elements that are in each of the sets. And there is basically, I can go one number at a time and just kind of decide where it is, and we'll go from there. And I guess I'll just go in order. I'll start with the number 1. And so the number 1, it's inside the rectangle, and by definition, any point that's inside the rectangle is a member or an element of set U. It's also inside the A circle, so 1 is also considered an element of set A. So it's in both the universe and in set A, but it's not anywhere inside this B circle, so I won't put 1 in set B. Now I'll move to number 2. You don't have to do these in order, but it just kind of makes sense. Now 2 is inside the rectangle, so it's part of the universal set. So in my listing of the elements, the universal set, I'm going to put the number 2. But 2 isn't inside the A circle, nor is it inside the B circle, so 2 won't belong in the listing of the elements of the A set nor the B set. Now I'll move to 3. 3 is a lot like 1. It's inside the Venn diagram, so it has to be part of the universe. It's inside of set A, so it needs to be part of set A. And it's not inside the set B circle, so it's not part of the set B. Now I'll keep going and I'm knocking these out and marking these out so I don't forget one. So I go to the 4. The 4 is just like the 2. It's inside the rectangle, so it has to be part of the U set. And it's outside the A circle and it's outside the B circle, so it's not going to be part of the A nor the B set. 5 is just like the 1 and the 3. It's inside the rectangle, so it's part of the universal set. It's inside the A circle, so it's part of set A. It's not inside the B circle, so I won't include it in set B. 6 is inside the rectangle, so it's part of the universal set. It's outside the A circle, so I won't put it in A because the A is that circle and 6 is not part of that. But it's inside the B circle, so I'll put 6 in the B circle. The nice thing about taking the numbers in order is that my sets are coming out alphabetically, which I kind of prefer. Now I'll move on to the 7. 7's inside the rectangle, so it has to be part of the universal set. 7 is also inside the A set, because the A set is there. 7's inside the A set, so it needs to be in my listing of the elements of set A. And it's also inside the B set, because the circle that contains everything in the B set, 7 is in it, so it needs to go in the B set as well. Move on to the 8. The 8 is just like the 6 in that the 8 is inside the rectangle, so it's part of the universal set. 8 is outside the A set, so I won't put it with the A, and it's inside the B set, so I'll put it with the B set. 9 is kind of like the 7, or just like the 7. It's part of my diagram, so it's in the universe. It's in the A circle, so it belongs in the A set. It's in the B circle, so it belongs in the B set. And the last number I need to place is the number 10. Number 10 is inside the rectangles, so it's in the universal set. It's outside the A circle, so it doesn't belong in the A set. I'll cap off the A set now because I'm done filling it up. And I'll put it in the B set because it's in the B circle. So those are the elements of the sets U, A, and B for this diagram. The first few problems in the homework, that's all we're going to do, is we're going to be given Venn diagrams and we're going to be asked to fill them up with numbers. And it's not a particularly hard skill, so hopefully it goes pretty quickly. I don't think there's too many of these problems. So problem 1 is going to be your homework, so if you want to pause the video and try to fill in the elements of the set U, S, and A, and again, U is going to be the whole rectangle. S is like the A in the last problem, E is like the B in the last problem, and hopefully you can fill out the elements. There's kind of too many elements here, and it's going to take a while to do, but hopefully you can get through it. And if you can't get through it, watch me do number 2, which is an easier problem, and we'll go, and then we'll meet up with number 3, I guess. So I want to fill in the A set, the B set, and then for whatever reason this is called E. I still don't really know how to make Venn diagrams and fill them up with numbers, so most of the filled in Venn diagrams that you see in this section are something I just stole off of Google Images. So eventually I'm going to figure out how to create my own Venn diagrams that are typed up, but haven't got there yet. So let me fill in the names of these sets. So E is going to be the name of the universal set, which is really kind of an odd name for the universal set, but I'll live with it. And then the left set circle is called set A, and the right circle is called set B, which is kind of the standard. And I'm just going to go one number at a time. I'm going to start with number 1. Number 1's inside the rectangle, so it's part of the universal set E. It's inside the A circle, so it's part of the A. It's not part of the B circle, so I won't put it in B. Now I'll move to 2. 2 is inside the rectangle, so it's part of the universal set. It's also inside the A circle, so it needs to go in the listing of the A elements. It's also inside the B circle, so it's going to be listed in the B set as well. 3 is going to work just like 2. It's inside my rectangle, so it belongs in the universal set E. It's inside the A circle, so it belongs in set A. It's also inside the B circle, so it belongs in set B. I'll move on to 4. 4 is part of my universal set. Every number is always part of the universal set. 4 is outside the A circle, so I won't put it in A, and it's inside the B circle, so I'll put it in B. 5 is just like 2 and 3. It's part of the diagram, so it's part of the universal set. It's inside the A set, so I'll put it in the A set, and it's also inside the B set. It's in all 3. 6 is going to work just like the number 1. It's inside the rectangle, so it's part of my universal set. It's inside the A circle, so it goes in my set A, but it's not inside the B circle, so it won't go in set B. 7's kind of in the same position as the 4, so I'll make 7 as part of my universal set. It's outside of set A, so it won't go in set A, but it's inside set B, so it'll go in set B. 8 is just like the 7. It's inside my rectangle, so it's part of the universal set. It's outside the A circle, so I won't put it in the A, and it's inside the B circle, so I'll put it in the B. 9, again, it's part of the universal set. Kind of ran out of room there. It's in the A circle, so I'll put it in the A set. 9 is not in the B circle, so I won't put it in the B set. 10 is inside the rectangle, so it's part of the universal set. 10 is not in the A set, so I won't put it in A. But 10 is in the B set, so I'll put it in B. Now I'll move on to 11. 11's in the rectangle, so it's part of the universal set. It's outside the A circle and it's outside the B circle, so it doesn't belong in the A set, nor does it belong in the B set. And the last number, 12, is just like 11. It's inside the rectangle, so it belongs in the universal set. It's not in the A circle, so it doesn't go in the A set. It's not in the B circle, it doesn't go in the B set. So these are the answers to problem 2. These are the sets that are described by that Venn diagram that actually has an E for the universal set name. It's nice that I took the time to write the numbers in ascending order. That's kind of preferred, especially when I'm grading. It makes it a lot easier if your numbers go from smallest to largest. And if you have letters, if they go alphabetically. So in 3, you're asked to fill this in, and this name right here shouldn't be U, it should be the other funky name, the symbol that I can't draw that. This is that Z, that's the Greek letter Z. I physically have no idea how to draw that. Sorry. So anyways, you want to fill in those, and that's a much friendlier diagram to fill in because it just has, what, 1, 2, 3, 4, 5, 6, 7, about 9 letters. You want to put them in alphabetically and just get them in all the right spots. And so pause the video and do that. That's number 3. Now going to number 4. 4 again, it's called the funky name Z, and I think I can get them all in. So on this diagram. So first thing I'm going to place is a number 1. Every number is going to be part of the universal set. 1 is also in set A, it's not in set B. The number 2 is going to be in the universal set. It's in set A, but it's not in set B. Number 3, it's inside the universal set. It's also inside the A set, so I'm going to put it in set A. And it's inside the B set, so it's going to go in set B. 4 is just like the 3. It's part of the universal set. It's inside the A circle, and it's inside the B circle. 5 is part of the universal set. 5 is inside the A circle, but it's not part of the B circle, so I won't put it in B. 6 is part of the universal set. It's not inside the A circle, so it doesn't go in A, but it is inside the B circle, so it goes in B. And the last 4 numbers, 7, 8, 9, and 10, are only going to go in the universal set. They're not going to go in the A set, nor are they going to go in the B set because they're outside the circles. So I'm going to go 7, 8, 9, and 10, and put those in the universal set. And I already put the begins and ends in, but I'll end it harder. So that would be a diagram for number 4, or that would be the interpretation of the sets that make up the diagram in number 4. So number 5, it has a set A, B, and C for you to fill in. So we want to do the same thing. We want to find out all the elements of A, all the elements of B, all the elements of C, and you might as well go from the smallest number to the largest. So the first number I would place in number 4, or question 5 is probably the 4, and that's going to go in the universal set. It's going to go in set E, A should I say, but it's not going to be in B, nor is it going to be in C. When you go to place 5, it's going to be part of the universal set Z, that's this symbol, and it's going to be in set C, but it won't be in set A, nor will it be in set B. So hopefully you can get those filled in while I do number 6. And notice how I give myself the shorter problems. Sorry about that. So on number 6, I want to fill the Venn diagram in, and I'm just going to do it up here. I'm going to make some effort to draw this symbol. So I need to fill in the universal set, the elements that are in the A circle, the elements in the B circle, and the elements in the BC circle. I'll start with the number 1. The number 1's part of the universal set, so it goes It's in the rectangle, so it's part of the universal set. And then it's also in both the A circle, because the A circle, contains that 1, and it's also in the C circle. So that 1 is also going to be in the listing of the A elements, and it's going to be in the listing of the C elements, but it's not in the B circle, so it's not going to be in the listing of the B's. Move on to 2. Every number is part of the universal set. 2 is outside the A circle, it's inside the B circle, so it belongs in the B circle. It's outside the C circle. 3 is kind of like the 2, where it's only in the universal set and then one other set. 3 is in the universal set. It's in set A, but it's outside the B and the C circle, so 3 is only in the universal set and set A. 4, every number here is part of the universal set. 4 is inside the A circle, so I'm going to put it in the A set. 4 is also inside the B circle, so it belongs in the B set, but it's not part of the C circle, so it doesn't belong in the C set. 5, which you can't even read anymore, that's the number 5 right there. That's the number that's in every single circle. 5 is in the A circle, it's in the B circle, it's in the C circle, and it's part of the universe. If I was given a blank Venn diagram and I was asked to fill up that blank diagram with the elements of a set, I would more than likely put that 5 in first, but I guess it doesn't matter. 6 is not in the A circle, but it's in the universe. 6 is in the B circle, and it's in the C circle. So I'm going to place the 6 as part of the universe. It's outside the A circle, so it won't go in the A. It's inside the B circle, so it'll go in the B. And it's inside the C circle, so it'll go in the C. 7 is only in the universal set and in the set C, because 7 is outside the A and the B circles. So I'm going to put 7 in the universal set and 7 in set C. 8 is outside the circle, so it's not going to be in A, B, or C, but it is going to be part of the universal set. 9 is similar. 9 is not in any of the circles, so it won't be in A, B, nor C, but it'll be part of the universal set. And the last number, 10, it's in the universal set, so I'll put it there. Close out my set. 10 is not in the set A circle, so my set A is done. 10 is not in the set B circle, so my set B is done. But 10 is inside the C circle, so it also belongs in the C set. And that's everything I think that's filled in properly. So that's a nice skill to have, to be able to take a Venn diagram and break it down to the sets that are defined by it. 7 would be your next problem to do, and it's not so bad because it only goes up through 10. It's kind of nice when these things don't have a ridiculous number of sets or elements in the sets. So you can pause the video, get that done. Check your answer every time I do a problem. Somewheres in my work there are answers. So if you just scroll to the very end of the section, there's going to be answers. Every single section that I do, there's answers written at the very last page or two. One last one I think of this kind. Number 8. So I need to fill in my U, my A, my B, and my C. And I'm going to go from smallest to largest. I'm just going to mark out the numbers as I use them. So 2 is going to be part of the universal set, and it's going to be part of A, but it is outside the B and the C circle, so I won't put it in B and C. 3 is going to be part of the universal set and part of set B, but 3 is outside the A circle and it's outside the C circle, so I won't put it in any other place but the universal set and set B. 4 is only in the universal set in set A. It's outside the B and the C circle. 5 is only in the universal set in set C. It's outside the A and the B circle. 6 is in A, B, and the universe. So 6 is in the overlapping part of A and B. The only thing that's not in is the C circle. So I'm going to put 6 in the universal set. I'm going to put it in set A, and I'm going to put it in set B. There's no 7, so I'll move to 8. 8 is just like the 2 and the 4, where 8 is in the universe. It's in the A set, but it's not in any other sets. 9 is in the universe. It's in the B set, but it's not in the A or the C. 10 is in the universe. It's in the C set, but it's not in the A or the B. There's no 11. I've moved to 12. 12 is just like the 6. 12 is part of the universe. 12 is in the A set. And 12 is in the B set, but 12 is not in the C set. 15 is part of the universe. It's in the B set and the C set, but it's outside the A set. So the 15 I'm going to put in the B set. I'm going to put in the C set, but it's going to be outside the A set. And then the last number, 20, it's in the universe, it's in the A set, it's in the C set, but it's not in the B set. So 20 is going to go in the universe. It's going to go in the A set. It's not going to go in the B set. It's going to go in the C set. So I'm going to close out my set notation. So I think that's a reasonable depiction of the answer to number 8. That would be all the sets that are described by that Venn diagram listed out in roster form. I think we're moving on to a new kind of problem. The next problem, what it wants me to do is it wants me to use a diagram to find an intersection problem. And this is reasonably easy to do if you know what the picture of the set denoted by the question looks like. So the way to solve this problem is create a diagram, a shaded diagram, how about that? A shaded diagram for A prime intersection B. If I had to guess, when I did section 1.5, somewheres in section 1.5 I've already created a diagram for A prime intersection B, and this is why I keep referring to my homework or my lecture from last time, because the sections really do kind of blend together. So in this is directly from my video in section 1.5. One of the examples that I did is I found a Venn diagram for A prime intersection B. What I'd like to do is just steal the answer. The answer to what A prime intersection B is that region right there. I'm going to go ahead and create it just in case you haven't looked at this for a few days. So if I wanted to create a diagram for A prime intersection B, I'd make a 2-circle Venn diagram. I'll kind of be a little more efficient here than I was in the last section. A prime is going to be anything outside the A circle. So there's a reasonable picture of A prime. B is going to be anything inside the B circle. A prime intersection B is where both shadings exist at the same time. So A prime intersection B is going to be this region, and that's what I showed here. This is A prime intersection B because it's the overlapping region between the pink A prime shading and the blue B shading. What I'm going to do to answer the problem is I'm going to take this final shading and put it on the Venn diagram that I'm asked to find the set that it's describing for. So this is a shaded region of A prime intersection B. If I have a Venn diagram and I apply that shading to the Venn diagram, then the answer is just the elements that are in the shaded region. So the answer to this example, A prime intersection B, is the set that contains the numbers, I think that says 6, 8, and 10. So Venn diagrams could make it really quick to do unions and intersections and complement questions if you can quickly get a picture of the Venn diagram. So rather than doing what we did in section 1.4, physically listing out the elements of the sets and figuring out how they combined without the diagrams, in this section we're going to use diagrams to help us answer the questions. And most of the diagrams that we're going to be asked to do in this section were diagrams that we did in section 1.5. And so if we kind of peek back to our section 1.5 homework, then we'll be able to know what the diagram looks like, and then it'll be really easy to get the answers. Oh, beautiful. I finished this problem up using a couple pages, but I basically just summarized what I did on these couple pages, all kind of in line. Okay. Oh, right. So next example, for this set I want to find A union B prime intersection C. I'm going to thumb through my work from section 1.5 and hope like heck I have done that shading already, so I don't need to create it. And I'm physically just flicking through my pages right now of the work that I did when I created the video. And it's not jumping out at me just yet. And if I don't find it, I'll create it. Finally. So in my video for section 1.5, the last example that I did before the homeworks 10 through 23 said find A union B prime intersection C. So I just did that. If you watched the video for section 1.5 recently, then you've watched me do this, or you fast forwarded because you knew how to do it anyways. So what I'll do now is I'll take what A union B prime intersection C equals by thumbing through this example and getting down to the answer. So there is the region that A union B prime intersection C represents. What I'm going to do is I'm going to transfer that region to the answer, and any element in that region is going to be my answer. So transferring that region to my answer, that region is this region here. So this is what A union B prime intersection C looks like. And so the answer to this example is going to be the set that contains the numbers 5 and 10. I'll not be so lazy for the rest of the problems. I'll go ahead, or some of the rest of the problems, I'll show you how to do the shadings, just in case you're not good at doing the shadings. But that's the lazy way. That's the way I envision you doing most of the homework problems, because most of the homework problems will physically give you a problem to shade that we've already shaded. And so the big hint here, as you're doing the homework in this section, first thing we have to do is find the shaded region represented by the union intersection complement problem, apply that shading to the Venn diagram, and then any number or letter in the shaded region will be part of my answer. And then many of the regions are the same as we did in section 1.4. Alright, so let me attack number 10, and you can do number 9. So on number 10, in order to figure out what my answer is, I need to know what B prime is in terms of a shaded region. And in terms of a shaded region, on a blank Venn diagram, B prime is any area that's outside the B circle. So this is what B prime looks like. You know, maybe not the best B prime in the world, but it's got to be good enough to answer this question. So now I'm going to apply that drawing to that shading to my drawing or my given problem. And what you're going to apply is the shading for A prime to yours. B prime, again, is anything that's not inside the B circle. So I'm shading B prime on the given diagram. So there's a picture of B prime. Anything that's shaded right now is going to be part of my answer. So for number 10, I can write the problem B prime equals, and I'm going to go alphabetically. So A is part of the shaded region, so I'm going to include it. B is part of the shaded region, I'm going to include it. C I'm not going to include because it's not shaded. D and E and F I'm not going to include. G I'm going to include. H I'm going to include. I am going to include. And J I'm going to include. So I've made a mark through every single element so I know that I haven't missed something. So I put X's through the ones that didn't belong in my answer. I circled the ones that belonged in my answer. So B prime for this diagram would represent the set that has A, B, G, H, I, and J in it. For your problem 11, if you look at the answer to 1.4 number 3, it's going to give you the shading. I'm going to do my shading for problem 12, and I'm going to do it on a blank graph just so I don't mess up the one that I need. So I need to find a shading for A union B prime. I could do this all in one graph to be efficient. First I'm going to shade A. A is anything inside the A circle. I should make the drawing smaller so my shading is easier. And for unions, you don't need multicolors. For intersection, you need where colors overlap, so I'd need multicolors. So there's the A part, and now I'm going to put the B prime part in. And B prime is going to be union together, so anything that's shaded when I shade A or when I shade B prime, this is not B prime, that's B, I'm shading B prime. If you can imagine, I used to get unsatisfactories in art when I was in grade school, if you can't tell. So this is a picture of A union B prime. Takes the entire A circle, unions it together, adds everything outside the B circle to it. Now I'm going to apply that to my diagram that's been given. So basically I need to get that little region unshaded. So that's applying A union B prime. So this is a shading of A union B prime applied to the document. So the answer for number 12, I'll go alphabetically. A needs to be part of my answer because it's shaded. B needs to be part of my answer, it's in a shaded region. C needs to be part of my answer, it's in a shaded region. D doesn't, E doesn't, nor does F. G needs to be part of my answer. H needs to be part of my answer. I needs to be part of my answer. And J needs to be part of my answer. So I'm semi-careful to make sure I'm not missing a letter. Either I put a circle around it if I'm keeping it in my answer, I cross through it if I don't need it, just so I don't miss one. And I like to write things alphabetically if they're letters, ascending order if they're numbers, just because it will make my grading a lot easier to do. Alright, so for your problem 13, if you look at the answer to 1.4, number 5, that will give you the shading. Let me do mine by hand. So first I want to do the inside of the parentheses, and then I'm going to prime it. So for 14, if you're watching this, I'm going to do the inside the parentheses. And that's asking me to intersect A and B prime. Intersection I'm going to do with two colors. So I'll make my A circle and my B circle. So I want to do my A circle in one color. If it was union, I can just do them all on one graph and be done in one color. But for intersection, I need multicolors. And now I'm going to do B prime on this same graph. B prime is just anything outside the B circle. So that's putting both A and B prime on the same graph. So A intersection B prime is what I'm trying to do, the inside of the parentheses. A intersection B prime is where the two shadings overlap. And those two shadings overlap in just this region right here. So that's the inside of the parentheses. Done. Unfortunately, that's not what I'm asked to find, because what I'm asked to graph is A intersection B prime prime. So I want to find the complement of this, and the complement of this, I shade anything that was empty, I make empty anything that was shaded. So the shading I'm going to need is going to have everything but that little part of the A circle shaded. So the whole B circle and anything outside the circles as well. So that's a representation of A intersection B prime prime. And now I'm going to apply that to the Venn diagram in this problem. So if I apply that shading to the Venn diagram in this problem, really, the highlighters make it really nice because you can shade without losing sight of the sets. Alright, so that's the shading for A intersection B prime prime. And now I'm just going to write down the elements that are in it. So my answer for number 14, I can write the problem with the answer. I could just write the answer one letter at a time. A is not in the region I'm worried about. B is not in the region I'm worried about. C is, so I'm going to include C. D is, I'm going to include D. E is, F, G, H, I, and J. So again, I applied the shading to the diagram and was very careful to make sure I've used every letter. I don't use A, the big A and the big B, because those are the set names. And I got everything that was in the shaded region in my answer. So your homework should go really quick because you've done all these already. If you did section 1.4 or 5, should I say, you don't need to reshade unless you're not feeling good about shading, then you can shade it again. Ugh, really. A union B prime prime for 16. So for 16, first I need to do the inside of the parentheses. So first, I have to do A union B prime. That I can do in one drawing with one color. It's intersections that I probably need two drawings and two colors. So I'm going to take the A circle, and I'm going to union in the B prime circle, which is everything outside the B circle. So this is what the inside of the parentheses looks like. That's a drawing of A union B prime. But I'm asked to make a drawing of A union B prime prime. And to draw that, I complement the drawing that I just did. And this is actually going to be kind of easy, because when you do a complement, any area that was white becomes shaded, any area that was shaded becomes white. So A union B prime prime, it's just going to be this region right here. So I have now A union B prime prime shaded. I'm going to apply that shading to my problem. I think I could write that answer probably without even having to go through every single letter. It looks like it's just E, D, and F. So I'm going to say the answer to this is E, D, and F without even writing A of the ones that aren't clearly in it. I'm not even going to take time to worry about those. There's only 3 elements there. It's easy to get them all. Okay, 18's an easy shading. That's my homework. If you want to start working on yours, maybe 19, which apparently is same as 1.4 number 2 in terms of the shading. So for 18, A intersection B prime, it's an intersection. I probably will take 2 graphs to do it. So I'm going to draw the A circle, which is anything inside the A circle. Then I'm going to draw the B prime circle, which is anything outside the B circle. I use 2 colors when I do intersections because the region that we need is the region where the shadings overlap. So this is the beginnings of getting a graph for A intersection B prime. The graph of A intersection B prime is going to be the region where I have the multicolored shadings. So the region that I'm worried about for my problem here is this region. That's the region A intersection B prime. I'll apply that shading to the problem, the graph that's given in the problem, and any number that's in that set is going to be part of my answer. And again, I think I can just write the answer down without having to go through every number. So for 18, the answer is going to be 1, 2, 3, and 10. Alright, move on to 19 and 20. I'll do 20, you can try 19. Well, they look a lot the same, don't they? I like that so much. So we did A intersection B prime. Let me for number 20. So you're not doing number 19, change it to A prime intersection B. Just because I don't want to do the same problem that you're doing, and when you watch, if you open up the problems, that should be changed if I don't forget to change it. So let me do A prime intersection B. First I'm going to shade A prime. A prime is anything outside the A circle. Then I'm going to shade B. When I do intersections, I do 2 colors. So I shaded both A prime and I shaded B. So now I can make a graph that's nicely drawn of A prime intersection B. A prime intersection B, because it's an intersection, I need the region where the shadings overlap. That's going to be this region right here. I'm going to apply that to my drawing. And when I go to do the answer to number 20, any number that's in that shaded region is going to be part of my answer. And it's getting harder to read, but I think that's 5, 6, 7, and 9. So my answer to number 20, I has the numbers 5, 6, 7, and 9. That's the letter B. I'm not going to use it. That's the name of the set. So if you need the practice of creating the shadings, you'll keep creating the shadings. If you don't need the practice of creating the shadings, then flick back to section 1.5 and look at the answers. So if this, for section 1.5, these are the answers. So, oh, this says look at section 1. Really? I think that should probably say look at section 1.5, number 2. And if all of these should say look back to section 1.5, it's because I changed the numbers. So if you're trying to follow my hints, like if you're doing problem 15, you want to look at section not 1.4, section 1.5, number 7. I have an answer for section 1.5, number 7, and theoretically, you already did it anyway. So all of these 1.4s are supposed to say 1.5s. Sorry about that. It's just that I started adding more sections because my sections got too long and then my numberings got kind of messed up. But the shadings do exist. And so yeah, this is probably, you're looking at 1.5, number 2, which is one that I did in the video. You can maybe not see it unless you're watching the video, unless you took notes of me doing it. So you can create it if you have to. All right. I had no hints on 21 or 22. Let me handle 22. So for 22, the first thing I want to do is A intersection B. And that's not terribly hard. I could even do that without doing extra shading, but I'll do it in a couple steps because I like to just show all the steps that need to be showed. So to do A intersection B, I'll do the A circle in one color, the B circle in another color, and the overlapping regions, the regions where there's 2 colors, is going to be the region that we'll call A intersection B. So A intersection B drawn nicely is that region. That's not what I need. What I need is A intersection B complement. And again, to do a complement, anything that wasn't shaded becomes shaded. Anything that was shaded becomes white. So A intersection B complement is going to have everything but that little overlapping regions between the 2 circles. So now I'm going to apply that to the drawing. And maybe not so nicely, but it's at least being applied. So basically, that's applying the shading. And again, if you could do this without actually physically shading it, because you could do it in your head, that's completely fine. I'm just trying to show you everything that's the maximum of what you'd have to do, but you can maybe do less. So this is a picture of A intersection B prime. So I'm going to take the numbers 1, 2, 3, not 4, 5, 6, 7, 8, 9, and 10, and put them in my answers. Okay, I have a sense we're going to be going to the 3-set Venn diagrams now, which are a little bit less enjoyable. Now still one more 2-setter than the 3-setters. And they're not near as many 3-setters. They're really kind of unpleasant to do, so I'm going to do a couple of those. So 24, and you can try 23. 3, and again this must be 1.5 number 6, and you might not have that in your notes if you didn't copy down when I did it. So let me do A prime union B to start, and I can do that on one graph in one color. With unions, you need shading anywhere. So first I'm going to shade A prime. A prime is anything that's outside the A circle. Alright, and now I'm going to add to that the B circle. And I can do it in one color because in the union it's any place there's shading. You don't need overlapping colors, it's not important. So that's A prime union B. And now I can make the graph of A prime union B prime. Anything that's shaded becomes white. Anything that's white becomes shaded. So the graph of A prime union B prime is going to be that region. I'm going to apply that to my graph. And my answer are going to be any of the numbers that are in that shaded region. So for number 24, my answer is going to have the numbers 1, 2, 3, and 10. All right. Keep going here. And I don't think there's too many more. We're going to have, well, 26, 28, and 30, so I have 3 to do. You have 27, 29, and 31. You have 3 to do. So we both have just 3 to do. 6 if you're doing them along with me. So close to the edge here. So 26 wants me to do A intersection B union C prime. If you want to work on your 27, I use the same diagram. You're doing A intersection B prime union C. Apparently I did that shading in a video. Let me do mine to start. I think I can maybe be efficient with the A intersection B. The A intersection B is just where the A and the B circles overlap, and just to save a little bit of time on the shading, and I think it's something you can handle. The A intersection B part, I'm going to add first to this. The A intersection B is going to be just that right there. It's the region where the A and the B circles overlap. So that's kind of a slick way to do A intersection B without physically doing the two separate graphs in separate colors and combining them together. So that's the A intersection B part of this. And now I'm going to union that with C prime. So to this graph I'm going to add in one color, because in unions you don't need multiple colors. To this graph I'm going to add everything outside the C circle. And so that's going to be a picture of A intersection B unioned with C prime. If I do that, fine. So it contains this region right here, and then everything that's outside the C circle. So let me try to apply that to this graph. And then somehow I just need to describe or list the numbers that I've got shaded. So I don't have 1 shaded. I do have 2 shaded. So in my answer, I'm going to put the number 2. I have 3 shaded. I have 4 shaded. I'm supposed to have 5 shaded. I don't know if it looks so much like it's shaded, so let me darken that in. So I have 5 shaded. I don't have 6 shaded. I don't have 7 shaded. I have 8 shaded. I have 9 shaded. And I don't have 10 shaded. So it's going to be 2, 3, 4, 5, 8, 9. So 2, 3, 4, 5, 8, and 9. It's missing the 1. It's missing the 10. I guess that must be a 7 there that I crossed out that I can't see anymore. 2 more. Alright, so let me handle 28 by making a graph of A intersection B prime intersection C. First I'm going to do A intersection B prime. I'm going to do it in two colors because maybe this one isn't so obvious. So this is my beginnings of doing A intersection B prime for number 28. Oops, we forgot to put the C circle in. So A intersection B prime. First I'm going to shade the A circle in one color. Then I'm going to shade the B prime circle in another color, which means not the B prime region in another color. It's not a circle, it's everything outside the B circle. So that's beginnings of my A intersection B prime. A intersection B prime is going to be the region above where both the shadings exist at the same time. So I have an A, B, and a C circle, and the region where all the shadings overlap is that region right there. So that's A intersection B prime. It's not done because now I need to intersect C with this. So what I'm going to do is to my A intersection B drawing, I'm going to add C. I'm going to add it in a different color because when you're intersecting, you look for that we have both colors. So I'm going to add the pictures of C to this drawing, and now I'm going to look where both shadings exist, and where I have the two shadings is this little region right there. So A intersection B prime intersection C, can't see it anymore, as a picture, the A circle, the B circle, and the C circle. It's just this little region right here. That's the region that I need to apply to the diagram. It's where the A intersection B prime shading, which is this region in blue, that was in blue, overlaps the C shading, which was in pink, and it's just that little region there. So I'm going to take that region and apply it to our Venn diagram. And the answer for number 28, A prime, A intersection B prime intersection C, is just going to contain the number 1. All right, one more, and I imagine it's horrible. That's not that bad. Oh, it's actually 2 more. I lied. Sorry about that. There's the horrible one with the parentheses. Oh, they keep going. Ugh. I was like so ready to be done, but we're not even close to done. I'm so sorry. Probably more sorry than you are. There's all the way up to 39. I knew I had to have some parentheses once. I was surprised that I didn't see them. So I'll just keep plodding along, and eventually we'll get done. Sorry about that. False advertising here. So I can do this whole thing on one graph, I think, in one color. So I'm doing number 30. First I'm going to do A union B. So I'm going to start off on this graph doing A union B. And A union B is the entire A circle and the entire B circle. You could do them in one color when there's unions because I don't have to worry about multicolors. So that's A union B, not done because now I have to add C prime to that, and it's a union so I can add it in one color. So I'm going to union C prime. So to my graph of A union B, I'm going to add the graph of C prime, and C prime is anything that's outside the C circle. So what I'm doing now is shading every bit of this graph that's outside the C circle. So that's a picture of A union B union C prime. It's anything in the A circle, anything in the B circle, anything outside the C circle. So it's almost everything. I'm going to apply that to my diagram. And applying that to my diagram, I get an answer for number 30. 30 is going to have the number 1, 2, 3, 4, 5, 6, it's missing the 7, it's missing the 10, but it has the 8 and the 9. So 1, 2, 3, 4, 5, 6, 8, and 9 is basically just missing the 7 and the 10. Alrighty. 32, that's where it gets nasty. So first I want to do A intersection C prime, and then I'm going to union it with B. So to do A intersection C prime, first I have to do A intersection C, and that's easy for me to do because intersections of sets are just where the sets overlap. So A intersection C is going to be where the A and the C circle overlap. And the A and the C circle, are going to overlap right there because it's inside the A circle and inside the C circle. Also a bit inside the B circle, but I'm not so worried about that. That's not what I need because I need to have a graph of A intersection C prime. And that's going to be a pretty big amount of shading. A intersection C prime is going to essentially have everything shaded except what I just shaded. So it's the only thing that's not going to be shaded is what I have shaded in A intersection C. So I'm trying to do this reasonably nicely. So that's the A intersection C prime part of this graph. The only part that isn't shaded is just that little region right there. And now I need to union this with B. So to union this with B, I can do it right on this graph in one color. And now I'm going to just shade in the whole B circle. Anything that's shaded from the A intersection C prime or from the B needs to be part of my shading. So the only region that's not shaded is where this 20 is. So the graph that I'm going to have for A intersection C prime union B is going to have everything shaded but that region with the 20. So my answer to number 32 in order has the number 2, 3, 4, 6, 8, I missed the 5, 5, 9, 10, 12, and 15. So the answer to 32 is 2, 3, 4, 5, 6, 8, 9, 10, 12, and 15. Alright, so 34, 6, and 8 to go. So 3 more problems. 34, first I want to do A intersection C. And then I'm going to union that with B. And that's a friendly-ish. I can do it in one shading, one drawing, I think. First I'm going to add for problem 34, A intersection C. You can pause the video and do 33. So A intersection C is where the A and the C circles overlap. So A intersection C is going to be this region. And now I just need to union that with B. So I'm going to this graph of A intersection C, throw in the graph of B. You can do it all in one color because unions, I'm not worried about overlapping regions. And that's it. That's B union A intersection C. I took A intersection C, which is where the A and the C circles overlap, union that with the B circle. Now I'm going to apply that to my graph. So my answer to 34 is going to have the numbers 3, 6, 9, 12, 15, and 20. I didn't even take the time to mark out the ones that I'm not including. I just circled the ones that I needed to include, and I got them all. You can tell I'm maybe speeding up the pace a little bit because I imagine you're kind of fatigued about this too. Alright, 36, when you'll do 35. So I'm going to start off with 36 by doing A union C, and I could do that in one color in one graph. Unions for me are one graphs, intersections I do two colors, two graphs, unions, one color, one graph. A union C, this is going to be the A union C part. I'm going to circle, color in the entire A circle, and I'm going to color in the entire C circle. So that's A union C. Whether I have the parentheses or not, that's what that is. And now I need to intersect this with B. And to intersect this with B, I'm going to draw B in a new color. And for intersection is where the shadings overlap. So where my pink and my blue shading overlap is where the region that represents B intersection A union C. And that's what that region, and that region. So I'm going to just try to draw that in the best I can. So there's the region that was represented by B intersecting A union C. So first I graphed the A union C, which was both the A and the C circle. Intersected it with B. I did a B in a different color. Found out where the pink and the blue shadings overlapped, and that's this region. Now I'm going to apply that to my graph. And the answer to number 36 is going to be 6, 12, and 15. All right. 38 for me. Oh, and that's it. And 37 for you. So in 38, I'd have to do the parentheses first. And in the parentheses, I'm first going to start off with A union C, and then I'm going to prime it. So the beginning of the parentheses is tackling A union C. And A union C is the entire A circle joined together with the entire C circle. So that's A union C, but that's not what the parentheses wants. The parentheses wants A union C complement, or A union C prime. So A union C complement is going to have the opposite of A union C. So where it's shaded, it becomes white. Where it's white, it becomes shaded. So A union C complement is going to have So there's the graph of the parentheses, A union C complement. It's everything outside the A circle and outside the C circle. Now I'm going to intersect that with B. And how do I intersect? I bring in a new color. I'm going to draw that picture of B on this graph. So B is anything inside the B circle. And intersecting, it takes me 2 steps because now I want to write where the colors overlap. That's getting almost hard to see. So I know in this region, I can definitely tell the colors are overlapping there. And that's the only region where the colors are overlapping. Because in this region right there, there's only the pink from the B graph. In that region right there, there's only the pink from the B graph. And out there, there's only the green from the A union C complement. So that's a picture of B intersection A union C complement, completely shaded. I'm going to apply that drawing to my picture. And I can write my answer. So my answer to problem 38 is going to be the set that contains the numbers 3 and 9. So hopefully you made it through it, and hopefully you have your homework done. And these things they're just a bit tedious. And you just kind of have to be up for doing them, because if you're not really focused, it's really easy to get sloppy and make mistakes. I get sloppy, but hopefully I didn't make too many mistakes. If you're not feeling good about this, I can make up tons more problems. Just let me know, and I can write you a bunch more problems with answers, because they're real easy to create. Other than I can't make the Venn diagrams by my computer so well, so I'll handwrite them if you need some extra problems. All right, so just one more section to do in this chapter, and then we get the review section, which is kind of the practice test. And the idea would be, after you do the first 7 sections in chapter 1, you should kind of review them, and then do the review section like it's a test before you watch the video. If you can do all the problems on the review, you'll be able to do all the problems on the test, because I never ever put a problem on the test that isn't just like something on a review.